All right, so before I dive into the talk, just a quick show of hands. How many of you are in the midst of rolling out IPv6 or have rolled IPv6 out? Okay, good. And for all of you, show of hands, how many of you have already been discussing things with your security and firewall folks in relation to v6 and v6 policy? Yeah, how many, show of hands, has that been going well? Yeah. So a good part of my job is going out and talking about v6, various issues, talking to people, sharing the experiences, and then sort of collecting it all and sharing the collective pain as we roll it all out. And one of the recurring themes is there are spectacular amounts of misinformation related to IPv6 and security, both in terms of problems, things that people think are better or worse. And so I decided that when I was doing the paper for this NANOG that I was going to try and sort of scrape together what are the things that I've been seeing and try and dispel some of the most egregious misinformation. So one of the things is, you know, you get to these security folks and like say, oh my God, IPv6, I heard it's this nightmare. We just don't know what to do. Nobody has any way of dealing with it. It's just a security disaster waiting to happen. There's just too many issues. And I usually sort of sit back and go, oh, really? So why don't you tell me in detail what particular issues that you're actually looking at? And I get a whole lot of blank stares or interesting sales pitches, depending on who. So what I found is that for the most part, what we're really looking at is if you have done security in v4 for years and you've dealt with networks in v4 for years, you're going to just start discovering as you go through that there's some syntax changes, but an awful lot of the stuff that you're seeing are all the problems we've had in v4. And same issue, same vulnerability, and more or less same mitigations. And as soon as you learn the new words, you go, oh, I know what that is. And it's not nearly as mysterious as you might think. There are certainly some myths and misconceptions of things that are just plain wrong, and I'll go through some of those and try and give you some useful factual information of what's actually there. And then, of course, the IETF, when they were looking at address exhaustion back in the 90s, everyone in the user and operations population said, we want IPv4 and DHCP-v4. We just need a lot more addresses. And the IETF smiled and nodded and said, oh, okay, but that's not elegant. And of course, elegant is a code word in the IETF for convoluted, confusing, and frequently not finished. And so they puttered around for a number of years and came up with a vastly more complex in many ways architecture as the lessons they had learned from v4. And so it has to be implemented in code, and of course code by definition is buggy. And there are entire new ways of doing entire classes of things. So there are definitely some new issues that are actual security concerns, not simply bugs or implementation issues. And I'll talk about some of those. But other than the myths and misconceptions, the other biggest thing I hear is FUD, you know, the fear, uncertainty, and doubt attack. And I'll talk a little bit more about that one as well. And there certainly is a lot of it around, and I think a lot of it is really unfounded. So first, let's talk about some of our familiar friends in the world of security issues, particularly on your local broadcast domain or subnet. ARP cache poisoning, of course, when you as a host send a packet out, you don't just send it out with the IP address. You actually need to be able to also put in the layer 2 or the MAC address into the packet, so you need some way of correlating those. So there's a protocol called ARP, which allows you to say, I've got an IP address, what's the MAC address I use for that? And when you get it, you stick it into what's called an ARP cache, a table that keeps track of the stuff you've talked to lately, so you don't have to do an ARP for every packet. Makes sense. And of course, poisoning that could be nasty. One of the other things that's less common in v4, and I'll talk more about why, but is technically possible is what's called a ping pong attack, where basically you can melt a point-to-point link by getting them to send useless packets back and forth between the two routers. And one of the other common attacks that is popular, if you can get away with it on v4, is if you can succeed in being a rogue DHCP server. So, more details on all of those. ARP cache poisoning is interesting because once I have gotten something in my ARP cache, I now know the MAC address and the IP address I'm supposed to be sending to get a packet to the host I want. If by some means someone can give the MAC address of a host other than the machine you actually intend to get to, and you put that in your cache, you won't ARP on the wire, you won't give the legitimate host a chance to give you the correct information again, because you already have that information. So the goal, of course, is for the bad guy to somehow get you to put the MAC address he wants you to use in for that IP address. Thereafter, you send the packets to the bad guy's machine instead of to the intended target. And what results is you have either some form of man in the middle or some form of denial of service attack that's now possible. Ping pong attack is if you have a subnet that has more than 2 possible addresses in that prefix length, i.e. it's a /30 or /24 for just that point-to-point link, what you can do is you can send a packet to an address that's in that subnet range, in that subnet mask, that isn't one of the 2 routers. And they will, in many cases, simply say, that's not mine, it's in the subnet, I'll send it out in the wire. And the only other guy there is the router, who will look at it and say, it's not mine, I'll send it out. And so once you get one of those packets in there, it will go bouncing back and forth until the hop count is exceeded. And if I can send a lot of those packets, I can basically clog that point-to-point link with all sorts of traffic and really abuse how usable that link is. Now, as I said, that wasn't as common in v4 solely because we don't have the address space. If we could, it would be we would all love to be able to just put /24s everywhere and do everything on 8-bit boundaries, but of course we can't because we can't subnet that wastefully. So we haven't seen it in v4, but it is completely possible. And the last one is rogue DHCP servers. And basically what happens is when you do a DHCP, you send out a broadcast, a DHCP discover that says, I don't know anything about my network, I need a DHCP server to give me a lease with all the information I want. If you are a bad guy and you can somehow hear those packets and insert DHCP offers out onto that wire, you can give them a lease with that information. And the most common thing to do is one of the things that's in a v4 lease is the default gateway you use to send all of your traffic out. So if I, as the bad guy, can get you to accept my lease with my box as the router, I now get every one of your packets. And I may be clever and send them on anyway, so it actually does what you want it to do, but I get to see all of those packets and maybe change bits in them. And then again, what you wind up with is the vulnerability of a man in the middle of the track or a denial of service attack. So, v6, everything in v6 is different. Well, sort of. So, just like in v4, when I send out a packet on the wire with an IPv6 address, a layer 3 address, I still need to send out a layer 2 or MAC address in the packet as well. And the way that I figure out who has that correlation of MAC address to v6 address, it's no longer called ARP. It's an ICMP-v6 packet exchange with neighbor solicitation, and it's called neighbor discovery. And if someone is out there on that wire with that IP address, they respond and say, hey, it's me, and here's my MAC address. I now take that and I put that in, it's called neighbor cache instead of ARP table, but I have a table in my kernel that has the correspondence of layer 2 and layer 3 addresses. As in v4, if I can get you to put an entry in your table that has my compromised machine or router MAC address and that IPv6 address, I can do all the same things. I can get all of your packets, and I can play man in the middle. I can do denial of service. I can do all sorts of interesting little things because you're sending the wrong box that packet. Sounds kind of familiar. If I configure my router links with something shorter than a /127, which only allows 2 usable addresses, I can send out a packet that fits within that subnet but is not the address of either of the routers, and they will happily send that packet back and forth until the hop count is exceeded. And last, in v6, we have changed things. In v4, I get my default route via DHCP. If I need to get a default route in v6, they decided that the DHCP servers were the least knowledgeable about the network and the router was the best source of information. So there are things called router solicitations, which is what the client sends out, hey, or who are the routers on my subnet? They will send router advertisement packets back. And included in that router advertisement is what your default route is. So in the same way that I can send out a DHCP discover, and if the bad guy managed to send a DHCP offer with a lease before somebody else, and the client takes it, rogue DHCP server, if I send out a router solicitation as a client, and the bad guy manages to send out a router advertisement packet with themselves as the default route, I take that, I put it in, and I now use the bad guy as the router. These should all sound disturbingly familiar. The only thing that has changed is the name. And the remediations are pretty much the same. If you don't want to have ARP cache corruption or neighbor cache corruption, and you want to be able to lock down which boxes send which wires at layer 2, you are going to be dedicated one intelligent switch port per everything that needs a network connection, plugging them in and having that switch monitor and lock things down. It's the only way you can do it in v4. It's the only way you can do it in v6. And then if you really need to get paranoid, you actually need to lock down network wires and actually do physical security on every component in your network in v4. That's truly the only way you can guarantee that no one can get packets onto your local broadcast domain unless they corrupt one of your hosts. Same thing in v6. For point-to-point links, it's very simple. Use 127s. There was a recommendation for a while that we should use 64s for everything, everywhere. Don't worry about the waste of address space for point-to-point links because it doesn't matter. Well, they're somewhat correct with that, though I would contend that really, really large is not the same as infinite, and that we will waste v6 space at some point, probably way sooner than we planned. But there's an RFC that actually explains the several vulnerabilities and why you should use 127s on point-to-point links. So if you're arguing with the group that wants to do that or the security group, there's the RFC that you can quote. For the rogue RA, yes?
I was going to say Jeff Doyle wrote an article on that a little bit. One recommendation he had was assign a /64 if you wanted for each point-to-point link, but only use 127.
The comment is that there have been recommendations that you assign a 64, but you only configure the /127 on the routers. And I have mixed feelings about that, and the reason is very simple. If you assign it by mistake, someone is going to wind up configuring it as a 64 at some point. If you can control things in an automated fashion where you can guarantee that you assign a 64 but only configure a 127, you've mitigated that risk. But I'm a big believer in human beings are very good at screwing themselves over. I would still recommend that you assign, but the key part is configure the router ends for the 127. Thank you. The last one with RAs, there are some RFCs that have come out, including 6105, because they realized that the rogue RA problem was an issue. And unlike rogue DHCP, where other than filtering DHCP packets and making sure that nothing other than the actual DHCP server can actually inject DHCP offers, there's really not much you can do in v4. In v6, there is actually a standard for it, and several of the larger switch vendors have implemented it on switches, though sales guys would hate me for saying this. Essentially, you can do the same thing with MAC level filtering on the intelligent switch, and you're going to have to buy the intelligent switch anyway. So it's not an extra selling point, but at least the plus side is it's in RFC, so at least all of your vendors will have done it the same way. So let's start talking about some of the interesting new things that the rocket scientists at the IETF have blessed us with. So this is the list of things that are out there. I'll go into them in more detail, and I'll do a little bit of sort of intro IPv6 to make sure you have a couple of the pieces of why. Extension header chains. The next three are all things relating to fragmentation. I will talk specifically about fragmentation. It has changed noticeably in v6, and they didn't quite think through some of the security implementations. The last one is that there are new tunneling technologies as part of transition technologies, of which there are also a wealth. I actually did an entire 90-minute presentation just on what transition technologies existed, and it was a cursory examination. So let's dive in. With v6, or with v4 rather, part of the interesting things when you're writing a router and you're writing ASIC code is that the header actually varies. You have to go into the header long enough to actually get one of the fields that tells you how long the header is. And so you don't know how much space to allocate to be able to handle n packets per second because you don't know how big every packet is. And there's options and all this other stuff, and so writing parsers for this was a little complicated. One of the things that v6 really did improve on is packet format is much cleaner. So ASICs are cleaner, and ultimately we get to v6 only routers where we do not have to support v4. So when we get to the point where at least our core is v6 only, we will be getting better packet rates out of our gear because it's easier to write better code. But one of the ways they did that was they said, the basic stuff is all in a standard packet and a standard size, and all of that extraneous crap that we used to put everywhere is now in a chain of extensions that you then have to go through after you need anything more than basic information. And we'll get into why that's fun shortly. The other thing to understand is fragmentation. So in IPv4, any box between the original sender and the ultimate destination of a packet who can't handle a packet of a certain size is empowered to munch, crunch, and abuse your packets and then send them on, hopefully in a way the destination can ultimately actually use them. As we all know, there's an entire class of what I call middleware boxes, which are anything that sits in your network and somehow feels a God-given right to touch your packet without you knowing it. Load balancers, NATs, firewalls, deep packet inspection, all sorts of other things. And if you've been in the field long enough, you start realizing most of the guys that write those apparently don't actually know the protocols and don't read the RFCs and break stuff all the time. One of the things they tended to break pretty regularly was fragmentation. So good news, bad news. The good news in v6 is the original sender of the packet is the only entity that is allowed to fragment packets. This now means that all of those people hiring grad students and summer hires and college dropouts to do all of their middleware box code can't screw up fragmentation anymore because they don't do fragmentation. Bad news, of course, is now we have OS vendors who have never had to write fragmentation code because they spit it out the NIC and that network thing takes care of getting it to the other end, are now writing fragmentation code. And there are issues with both the code and the original specifications of the fragments and how you fragment. The basic method is that what happens is anybody who says, that packet is too big for me to send to my upstream, is you drop the packet on the floor and you send an ICMPv6 message, packet too big, back to the original sender, and here's how big my upstream is, so please break it down into bite-sized chunks of this size or smaller. Path MTU discovery. So then the sender has to break them down into smaller packets. You can't, in theory, break down below 1280. There are a couple of weird edge cases, particularly relating to things when you start doing tunneling and encapsulation. So you can actually have fragmentation below 1280, and that's one of the vectors and one of the complications. Of course, in general with fragmentation, one of the first challenges is you have to make sure that the ultimate destination actually gets all of the fragments. And if it gets them all, it's got to have enough information to know that they're all actually part of one single packet and needs to be able to actually reassemble it such that it is then identical to the packet that the sender originally wanted sent. And of course, then the fun question becomes, gee, but what happens if somebody plays with some of this stuff in transit? So, more details on some of these problems. Extension header chain. So, as I said, the basic information in the v6 packet is in a standard size. All of the other extensions are in an extension header chain. They're working on it now, but there is no limit on how long that extension header chain is. v4 has a 64K header size max. If you try and ram more into it, everything will drop you on the floor. So 64K will probably break enough routers as it is, but at least there is some upper bound. Nothing in v6. So the first thing, of course, that happens is anytime that you are doing deep packet inspection, you have to go through the whole header because you need to know more than just the basic information of port and source and destination address. Stateless firewalls, which attempt to look at the packet and make a decision without having to hold state of a transaction beyond that one single packet, also have to go through all of that stuff, and usually those are written in a way that does not understand everything that's out there and is extensible as they add more possible extension headers. So they are frequently confused. And of course, the fragments themselves are a problem, and we'll get that in a second. So essentially what we've got is this guarantee that if I know that you are actually looking at anything beyond the basic header, for every packet that goes through, all I have to do is send packets with artificially long extension header chains, and I have basically destroyed your perimeter security device. Now, I can only do denial of service that way, but these guys are lazy. Usually that's all they do. There is an RFC talking about this, and several drafts relating to it that are referenced in that RFC. This one just came out. It's been in a draft for a while, talking about some of those issues and some of the possible remediations, including deciding whether you want your perimeter devices to even look through the extension header chain or only look so many bytes. The current trend seems to be in the IETF saying that for most operators, we should probably come up with a practical number and simply say, if you do this in your own internal network, you can have arbitrarily long extension header chains, but the odds are if you want to actually get it end-to-end anywhere on the internet, you better stick below n bytes or expect it to be chucked. The first of the fragment header problems. So one of the first things, of course, is that the destination needs to know that what it got was a fragment, so it needs to know that it needs to buffer it and wait for the other fragments for a reassembly rather than just handing it up the stack and saying, here's your packet. And the way they did that was they put in a fragment header ID. And as soon as you have a fragment header ID that is non-null in your packet, you are now told this is a fragment, it is not a complete packet. Unfortunately, they did not very well define what one could put in as that ID, other than that it be unique enough for a context, some fairly finite period of time, a day, a week. You're not going to have to assemble packets over 2 years. And that was it. Nothing about random, nothing about predictable, nothing about range, anything else. And so unfortunately, some implementations who didn't think what would happen if you could guess how to tag all of the fragments as of one packet or inject your own and make it seem like it's part of that whole packet. So they're predictable. There is a draft that explains that. Some of the things that happen or the exposures that gives you, you can predict the packet rate, so that gives you some idea of what chance you have of injecting packets. It's one of the ways that you can start figuring out what ports are open, because you can look at the packets themselves and see what's going on. We don't, in theory, have port scanning with v6, and I'll talk more about that later, but they are trying other techniques to figure out who are possible attack targets in your network. Depending on how your firewall does these things, you may actually be able to infer what rule sets and what firewall is being used between you and your target, which allows you to tune your attack to be more effective. You can get an idea of how many systems are actually behind some kind of middleware or firewall box, or you can simply start inserting crap in the packet so that none of them reassemble and just do a simple denial of service. Atomic fragments. Now this gets into some esoterica, and I'll say this right now. I am not at that level of deep security IPv6 protocol expert. When I'm actually playing with this stuff, I pull up the RFCs in one of my terminal windows by the side. So this is a fairly high level. If you want a deep dive, I'll get you a couple of guys that know more than anyone sane should. But essentially, if you have a packet that actually isn't fragmented, but you put a fragment header ID into it, that's allowed. Strange. And it has a name. It is called an atomic fragment. I'm not sure if they meant nuclear instead of atomic, but okay. Usually the way that you can trick somebody into doing that is you can send them a packet too big message, even though there's not a packet too big. They will think to fragment even though it doesn't need to be fragmented, and therefore you have something that's already, say, 1280. Therefore, it's unique and sufficient and never needs to be fragmented. But if you have that 1280 byte and you have a fragment header ID, it's atomic. One of the things that can happen with this and the other fragment attacks is, as you start playing games and weird things start happening, particularly when you're getting to that edge case where I talked about where you're doing tunneling or encapsulation, where it's sort of kind of 1280 limit, but not exactly, you can wind up with fragments that slightly overlap. And it's sort of like a buffer overflow in code, because essentially you then have it assembling packets in memory, and they sort of stomp on top of each other, which allows you to have things in the ultimate packet that are obscured possibly by some of the intervening boxes until you squish them all together. So you can sort of hide stuff in there that then might itself be packed up to an application that might be able to do a SQL insertion or a buffer overflow or some other attack. Once you can start playing with the packets and you can guarantee that you might get stuff that can't be easily detected, but the destination might use and might do unexpected things the source didn't want, you have various forms of interesting attacks. And again, there's a very recent RFC talking about some of those vulnerabilities. Last, we have tunnels. Because of the fact that an awful lot of backbones didn't have v6 available, because an awful lot of ISPs were not offering v6 to everyone who wanted them, Microsoft, to their credit, I mean, I love to bash Microsoft, but Microsoft was the OS vendor that implemented v6 first, committed to it most fully, and did the most RFC compliant implementations of v6 before anyone else. That was to their credit. Unfortunately, they also tried a little too hard, and they kept coming up with transition technology after transition technology, try and encourage people to do v6. In general, when we're looking at most people's perimeter devices, they are really firewalls that are ACL or ACL based. Essentially the knobs we have to twirl to try and catch bad stuff are source or destination IP address, port number, protocol number. If it's not obviously those in the header, what we are reduced to is immediately going to much more laborious deep packet inspection, signature-based detection, IDSs, all of those kinds of things that are much more error-prone and much more expensive. Unfortunately, there is a tunneling protocol called Teredo that comes on every Windows box from Windows 7 on, and it does not have to use a default range of addresses, port, or protocol number. It's not like GRE tunnels either that has a protocol number. So effectively, it is invisible to standard inspections. And if you can get admin privileges on that window box, you can turn on Teredo, and you can Teredo tunnel to some Teredo tunnel server outside your firewall, and the bad guy now has an effectively invisible tunnel all the way through to your corrupted host. Ta-da! So, the reality is that most of these, particularly the fragmentation attacks, are very sophisticated. They are hard to do. They are hard to make use of because they're the windows in which you can actually get the wrong thing to happen the way you want reliably are hard. And attackers are lazy. They will continue to use all the stupid stuff that has worked and all the rootkits that have worked for the last 8 years first because they just work. So in general, you're not going to see a lot of these in the wild. However, for good and bad, there is a toolkit out there. A guy named Fernando Gant down in Argentina has done a lot of the research. As a matter of fact, you'll see his name on a lot of these RFCs that I've mentioned. And he has developed a toolkit which actually has many of these fragmentation attacks. Because the IETF, when he first came to them, they all looked at that and said, oh, that's theoretical. That's never going to happen in the wild. Much too hard, blah, 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 blah. Why should we redesign our protocol? So Fernando, being Fernando, went home, spent a couple of weekends plugging away at his computer, compiled some stuff, came back to the following IETF to a whole bunch of people who went, and the draft suddenly stopped getting bogged down in committee. So the bad guys can certainly use these, but they're not all that useful for exploits. They mostly show that it works or not, because Fernando is a responsible individual. They're really good for testing. The link's there. Download the stuff. There's a new RFC, another one of the drafts that this would literally just turn to RFC yesterday. Apologies, the slides online will get updated in a week or two, but what's currently on the web isn't up to date because literally I changed my slides this morning for a couple of the RFCs. He talks about a lot of the issues that happen when you're sending v6 packets out on a primarily v4 network. Another one, I work for a vendor that does v6 stuff. That's why they send me out to do talks. So it may sound odd, but beat on your vendors. I will say this several times. If you say, as of right now, to all of your vendors, I will not buy anything new that is not IPv6 capable or for which you have a roadmap in which you will commit in writing to when you will have these features, I'm not going to buy your stuff. And the reason is, I go to our program managers and our engineers all the time and I say, we need this because people are rolling out v6 and if they don't have this in 6 months, they aren't going to be able to do this and they won't roll out v6. And engineering and PMs will look at me and they will smile and nod and they will say, how much? How much? Yes. How many dollars are we losing in sales because we don't have this feature? And as soon as I don't have a dollar value, they will smile and go, yeah, Paul, he's that guy. He keeps complaining about stuff. You guys get to wave checks. They will listen to you. So beat on your vendors now. Because the other is, if you got Infoblox to a degree today, I need feature foo in IPv6. And Infoblox says, you betcha, we will put it in our next release. Because of release cycles, engineering, and testing, and change control with the customers and all the rest of it, if that's out in 12 months, that is a stunningly aggressive schedule. And 18 months is pretty tough. So if you're rolling out v6 in the next 2 years, and your vendors don't have a feature that you will need critically to do your rollout, and you aren't beating on them now, in 6 months, you will be screwed because 2 years from now, it won't be ready. So another one of the ones that's out there is I go out and I say how many people are running v6. Less in this group. But you know, I talk to enterprise, I talk to government, and I usually start with the others. Who does not have v6 in their network? And I will get half the audience who will happily raise their hands. And I smile because they've fallen for it. And then I start with a few leading questions like, so you're running Windows 2012 for Windows Server? Do you do Windows clustering? Do you have any Windows 8 or Vista boxes on your network? How about current Mac OS, iOS, Android, Linux? Raise your hand if you have none of these on your network. Yes. Dead silence. I said, These all have v6 on by default. And if anybody turns on anything giving router advertisement messages, they will all bring up a v6 interface, and you have v6 on your network. And you don't know it. Congratulations. So there needs to be some comfort factors with it. Obviously, testing is huge. Figuring out everything you need in v4 is already a challenge because we usually have so many moving parts in our networks. That's somewhat of a challenge to begin with. Going through all of that and then figuring out what equivalent functionality you need in v6 that you need is an interesting challenge. Then getting your vendors to give you gear to test whether their gear supports what you will need in v6. You need to train your staff. You need to be able to know that you've got v6 running around and how v6 works and why that weird RA command on that Cisco or Juniper router being on or off and what flags it has on it really matter. Train them, send them to classes, get them links at home, even if it's a tunnel. Come to me afterwards, I'll give you some places and go train your staff. And again, and this is not the last time I'll say this, beat on your vendors. Get them to implement v6. And when you've got to a point where you at least have things sort of moving and your security stuff is at least usable, at least light it in your backbone and start logging and monitoring it so that you know when some person inadvertently brings up a Windows server on a LAN and starts sending out RA messages by mistake, and everybody starts configuring and trying to use it as a tunnel because quad A's are preferred to A's in an awful lot of stacks, and suddenly all your users break. Now we get into some of the once upon a times. And in v6, many of these once upon a times are more like the Grimm fairy tales because they tend to more eat with children eaten by witch than and they live happily ever after. But at least you need to know the stories. And one of the saddest ones is one of the most popular. And that is that v6 is more secure than v4 by design because IPsec was designed in and it's mandated. Here's the reality. So, first of all, the RFC, which has actually already been softened to should. It no longer says you must support IPsec with a v6 stack, it says should. Now the US government profiles still says must, and most vendor requirements still say must, but it only says should, and they said should support IPsec, and they never defined support. So the vendors who sell us our operating systems and our gear got to decide what support meant. And what support means is it is shipped on the distribution medium, and it is off by default, and there's usually no documentation, and if you can figure out how to get IPsec working in v6, congratulations. One of the other failures with the IETF was they could not agree on a standardized PKI, public key infrastructure, that they would recommend as part of IPsec. What this means is that if you can't do asymmetric keys via public key infrastructure, you are reduced to symmetric keys, which means that you must pre-configure both ends, which means that I can't have a centralized authority in which I can turn on John the new salesman's tag and my VPN hub and his laptop now magically use these credentials. I now have to have a provisioning method by which I can pre-configure John's laptop and pre-configure my VPN terminating hub before I can get v6 working. So, another good news, bad news. The good news is, if you already are doing IPsec in v4, and you already have VPN concentrators, and you already have software, and you already have some provisioning means that scales for your business to pre-configure the secrets in v4, you can use exactly the same thing in v6 and it will work exactly the same. The bad news, of course, is that it is 0% better than v4. Now, one of the other myths that I love, IPv6 is huge. There are so many addresses. We cannot possibly ever use them up. And the subnets are so big that it would take you centuries to scan them at 1 million pings per second. Because yes, there are 18 quintillion, which is 4 billion and change times 4 billion, really large number, 64 bits. Okay, you're right. If I started at 0 and went all the way up through a string of 64 bits worth of F in hexadecimal, yes, it would take centuries. However, that assumes that I have numbered my hosts across the entire 18 quintillion addresses sparsely. And we are lazy as human beings, so I have a host, a server, a mail server, and let's say I have numbered it 192.168.1.1. And I get my v6, and I sit there and I go, blah, 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 lots of gobbledygook alphanumeric crap, : 1 is the v6 address for the same server. That's easy, because I can remember it's the same. And I have just reduced 18 quintillion possible addresses to scan to 256. And it's very scannable. If for some reason I decide I'm still in v4 think and, oh my God, I can only have 4,000 to 6,000 hosts in a broadcast domain before it's an unusable segment. So why am I wasting most of 18 quintillion addresses? So I'm going to make all of my subnets /96 or /100 or some other thing. It breaks an awful lot of software stacks and other things, so don't do that. But that also reduces down the footprint. And the most common way that was originally recommended for generating addresses in v6 was you took your MAC address, which was 48 bits, and you split it in the middle and you stuck an FFFE in the middle of it, and that became 64 bits, and you now have the host portion of that address. Well, the first 3 chunks of your MAC address between the colons are vendor specific. They are pre-assigned. And we already know that if there's an FFFE, so I have once again, if I use EUI64 addresses, collapsed down, and 2 problems. One is I've massively collapsed down. I'm more like now something like 24 bits of possible instead of 64 bits of possible address space, which is still pretty bad to scan, but not as bad. But I can also make a pretty educated guess and start going through every one of the Apples or every one of the Intel chips in there because I know the manufacturer ID for the MAC address. So I'm already now down through 3 chunks and FFFE, and there's only 3 chunks of 16 bits left for me to actually be unique. So use the whole 64. Give every pool an entire 64 and let your server randomize completely across all of it. And the general trend now is that EUI64 seemed like a good idea at the time, but the reality is that things have changed in the 15 years since they started this, and security is much more an issue than transparency of addresses. So another draft explaining why that's a bad idea. And now we get to some of the fun stuff. We're all doomed. If we implement v6, every child in the US will die. Then we get to some fractionally less but equally specious arguments. Apps will break. To which I respond, apps already break. Apps break without a network stack under them. Firewalls won't work. Firewalls ever worked? ICMP is scary. How many of you had the discussion, we are disabling all ICMP because we don't trust it? Yes. And of course, as networking people, we just sit there and go, okay, can't debug my network. I'll call you when it goes boom. And there are some people that actually admit, we just don't understand. And they're true. We don't have a lot of large-scale operational experience in this. So there are things that we will discover that we don't know yet. And there's a class of individual that if you don't know and it seems like a risk, their default answer is no. So, apps. Yes, you will probably need to test everything. And when I say everything, I mean anything that has power going in and packets going out, whatever that is, that plays with those packets is going to need to be tested for v6. You know, I hate the analogy in some ways, but the only other thing that has anything like this scope was Y2K, where suddenly everything we had might blow up, and we actually had to look at everything for a while. This is at least as broad a possible reach. And you need to reach everyone, because v6 native is the default on emerging cellular networks, because they can't get enough v4 address space for a whole new deployment. They're natting v4, and at some point the cost of those CGNs and the performance issues and all the rest of it are going to be such that they are going to turn that off. So we need to be getting prepared for an awful lot of new devices, you know, and again, buzzwords, the Internet of Things, wireless, cellular, where v6 only mode may be the default, because it's also a much easier software stack to write, and it's much smaller. So yes, and of course the last one, which, and now we'll talk about them, there is no bad idea that was in v4 that you cannot reproduce in v6. So if you have people hard-coding IP addresses instead of using fully qualified domain names, if you're not checking your inputs, checking sizes, checking return codes, all of those things, you know, the things that we were supposed to learn in CS 101 when we were out drinking beer and not paying attention. Using relative domain names, search paths, instead of fully qualified domain names. Stuff for which we don't have source code anymore. Stuff not tested since Y2K. All of those things are things that we're living with now with all of the code that we have, and we're adding to it as we put in v6 compatibility. So we need to get our programmers to understand that they need to be responsible. You know, forgetting the whole, there are certain things where they actually need to change what network calls and all that. We need to get them to do the right thing with their v4 code first before we turn them loose on v6, if that's even possible. There was a very good presentation at the May RIPE last year where a gentleman decided that he was going to try and convert some of his code that was v4 only to v6 and make it work in v6 only mode as well as in dual stack mode. And he discovered a huge number of things that he hadn't expected and that didn't work spectacularly well. And he did a very good presentation and a very good slide deck. I would recommend that you go to your coding staffs and your DevOps folks and have all of them start reading this before they go into the lab. And as I've sort of said here also, my guess is if they actually read through all of this, they will discover there is stuff in their current v4 code that they really should have been doing better already. So, firewalls don't work. Okay, well, same. But we obviously can't turn on v6 if our firewalls and our perimeter devices and our security perimeters cannot cope with v6 threats. So what happens? Well, first of all, of course, test. Figure out if your box does. And one of them, simple test. Get a box outside of their device, put up a Teredo tunnel server on it, pop up a Windows 7 box, pop a Teredo tunnel through that device, and see if the bells and whistles go off. Because right now, I'm not aware of anybody who can do it gracefully and reliably. If I am wrong and somebody has improved their code, I would love to hear, please tell me after. Vendors are certainly working on it, and it's all the usual suspects who are doing the IDS and pattern detection and all the rest, and signature-based. But we're a lot closer to where we were with BitTorrent and Facebook detection 8 years ago than we are now. And of course, they've now improved. These days, if you get a box and they can't detect that someone's running a BitTorrent behind or that they're doing Facebook when they're not supposed to, ditch that vendor, get a new one. There are plenty that do it right. We'll get there with v6, but beat on them. Know what you need to ask for because you test and see what your requirements are. Beat on them until it works. ICMP is scary. Well, short of course, anytime that someone sits there and says all ICMP is evil and turns it off, you just turn around and shoot them between the eyes and hire someone new. I'm not sure how we're going to improve this quickly. Of course, maybe if after the first dozen they might get the message. But it really wasn't that scary. There were types, and you could say I only want ICMP echo or this, that, or the other. But to be honest, it really wasn't all that well defined, and there's certainly things that you would have preferred to be able to not allow in order to get stuff that you did need to keep your backbone running. And that was one of the other places where the IETF really did learn lessons. ICMPv6, well, first of all, it's necessary. If you want to be able to detect that your address is already in use, you want to be able to find a default route, be able to find a DHCP server, find DNS servers, get packets through and know that your packets didn't drop on the floor, because if the packet too big message gets thrown away, you keep throwing them into a black hole. If none of those things are important to you, then you can disable all ICMPv6. I would contend that if you don't have a default route, don't have DNS, don't have any assurance of non-duplicate host IPs on the same subnet, and you have no idea what size of packet to send out or whether it gets there or not, if you call that usable, more power to you. I would call that a brick. But v6 actually has those. And even more importantly, there's an RFC here that actually breaks down, this is the stuff that any sane person pretty much needs to run v6 usefully. This is stuff that if you're doing this particular thing like mobile IPv6, turn this on. And there's a group of stuff that basically is, this is interesting for research, but you probably don't want to turn this on in any sane network. And they sort of break it down into those three buckets, and it's quite well done. My usual recommendation is print this RFC out, laminate it onto a very, very thick 2x8 board, and walk over to the security person, and when they have questions, you just whack them in the face, hand them the board, and let them read. Okay, so the ignorance familiarity problem. For the most part, other than the normal things of training and the rest, there are people that will still quite vacuously and evilly tell you, v6 is evil incarnate. It's just wrong, or some other thing. My experience has been they fall into one of two buckets. They are a vendor, their competitors support v6 and they don't. Or, as I described it, they're selling FUD spray. You know, they have some weird security thing that they are supposed to scare the hell out of you about, and then immediately come back with, but we've got the solution in a can. I've pretty much not hit any third party that isn't one of those two. So if you get somebody who actually seems to have some clues about v6 and can actually answer some questions, and is still trying to tell you that you should do nothing with v6, that touching it at all is evil and broken, there's my bet. They're a vendor of one of those two varieties. So, the biggest thing that I can say in all of this is test. Get it in early, get a test bed that is as real as possible. Part of the problem right now is that we just plain don't know everything that's going to break everywhere. And we won't. We are just starting to see wide-scale deployments. There are some consumer broadband ISPs that have lit v6 and are starting to see approaching double digits of use. And some of the major services, you know, when they go to the top 10 used websites in the world, 8 of them are now at least reachable via v6. Europe and Asia are starting to use it. So we're starting to get there. But the really icky problems in networking, you know, NANOG's fun. We get to play with the stuff that works. You know, we play with backbones and routers and really large switches, which have done dual stack and worked pretty much flawlessly most of the time, because we're just shoveling bits. And it's been this way for years. The closer and closer you get out to the far edges, and the closer and closer you get out to human beings with hands who are not engineers, the ickier and crustier it gets. You start seeing laptops and Windows, and then you see printers, and then you see SIP phones, and then you just see just nasty things with the most broken code you've ever seen. And so the farther out to the edges you get, the harder it's going to be. That's where you're probably looking. And of course, apps. Vendor-supported apps are no better than anywhere else, but you usually have less leverage. You know, I can sit here and tell you why Oracle allows horrible databases to go out there, and Oracle probably could fix it, but never will. But we also all have homegrown code. And usually the assumption is that we understand it because we wrote it. Have them read that document I told you to check out. Know what you need. Test and figure out, this is what I need to do in order to actually use v6. and here's all the stuff I don't yet have, and then actually hold them to it. One of the other useful things, and it's been an eternal problem. I started out in the internet in '84, and my first job out of the service in '88, the OSI protocols was not yet an interesting footnote in textbooks. They were actually trying to make people believe that that was going to replace TCP/IP and DECnet and everything else. And I went to work for a company that was writing OSI protocol conformance test suites, automated test suites, which does explain possibly some of my bitter and twisted view of life. And very early on, what I learned was that what we were selling was protocol conformance. What customers thought that was, and what they actually needed and wanted, was multi-vendor interoperability. And they are very much not the same thing. There are a couple of hundred RFCs averaging something like 28 pages per that define various critical bits of IPv6. That is an insane amount of documentation to wade through to begin with. The scary thing is, it's my guess about 2/3 done. As we are rolling v6 out, we are just discovering all sorts of operational holes and ambiguities in key RFCs that are being changed as we speak. And if I, as a vendor, send somebody to the IETF and read the working groups and read the drafts and hire coders that are competent, still at best, what I am guaranteeing is protocol conformance. Well, the US government has been burned by this before because they still remember OSI, and they decided that they needed to have a profile that said, I can buy from multiple vendors and this stuff actually works. And it works with each other. And when it doesn't work, I can point at a vendor and say, you did it wrong. And so NIST actually did a profile called the USGV6 profile, and there's the link for it. And it includes usage models and things like the fact that as an end host, I don't need to worry about how to deal with a lot of the router advertisement messages because I'm not a router. Conversely, most routers are probably not going to do Slack or DHCP necessarily, at least until prefix delegation becomes more popular. So there are more obvious things that certain types of devices must support. So they break all of that down, they break down the relevant RFCs, and they mandate a testing body, the University of New Hampshire's Interoperability Lab, that you must actually test with and get a certification, or you can't claim you are interoperable and conformant. So even if you're not the US government, and I do a lot of talks in Europe and Asia, and I've talked to their government officials and they're saying, we're trying to roll this out and we don't know what we should tell our vendors. I say, look at this, use this as a model. And several European governments have actually used this as their starting point. And a number of large corporations have. Hold your vendors to this. And you can ask, there's a very easy question. Have you passed USGV6 certification? And if they say yes, you can look on the website and see if they're lying. And if they're not, ask them when they're planning on doing it. All right, I left a fair amount of time because this is the stuff that I know, but I know that you guys have had questions asked of you or have been told things that I may not have covered. So I'd like to open up the mics now and start with the what's your favorite fairy tale?
Hi, I'm Cody Chrisman with Wipro. I had to step out to go to the bathroom, but you had, so I might have missed it, I apologize if I did. You said we'll never run out of space. You had a slide for it, but did you ever cover that myth?
No, other than saying that we have, as an industry, done a very good job of predicting anything. You know, Vint Cerf publicly apologized for there will never be 4 billion computers ever on the internet, which is why 32 bits is way more than we need. So when someone comes to me and says, we can't possibly exhaust IPv6 address space, I go, uh-huh. The reality is that we have a lot more space, so we can do much more sane subnetting. And if you're interested, email me later. I have some slides on how to do subnetting plans or think about those things. we can finally do subnetting schemes that actually make sense out of one single block. We can get down to one prefix per AS in v6. You know, we're averaging 11 per in v4, but we're averaging 1 and change in v6, and that's likely to stay the same because we can actually do it all in one chunk because we can get a big enough chunk. So we can afford to be generous, but not actively stupid. And I say over and over again, really large and infinite are not the same number. Don't mistake them for each other.
Going back to the gentleman who had a presentation yesterday in the general session about the aggregation of routes and the routing tables and growing and whether it's really a problem or not. In IPv6, can that problem or what we're seeing there be rather amplified because of the size of the address space?
Theoretically, yes, at some point. What the RIRs are trying to do right now is do address assignments in nibble boundaries, so every 4 bits, so essentially not subnetting within one of the alpha or the hexadecimal characters within the address.
Right.
So they'll actually slide things. So for instance, Infoblocks originally we were going to get a /48 because of 64,000 subnets. It was more than we were ever going to use in subnetting. The problem was that we have 8 sites that don't have a private backbone and that have their own individual connections around the US. So we need, and no one will route longer than a 48 in the same way that no one will route longer than a 22 to 24 depending on your ISP and v4. So we simply said, we have 8 sites, and they said, fine, that's a 44, because that gives you 16/48s. So they just automatically rolled up. So, and most people are doing sparse allocation as well, including Aaron and Ripe. So if I get a 32,
Right.
they're actually going to reserve the contiguous chunk and mark it as used. So if I come back later and went, I didn't know what I was doing, I found out it wasn't enough, I need more space, in many cases they can simply give you the other half. You can simply change your prefix lengths and not even have to renumber the half you've already been using to keep you with one single prefix. So the odds are right now that, I mean, it's already a 10 to 1, and it's probably going to stay that way or get worse of v4 to v6 prefixes per AS. So we're a long, long way away from it.
Okay, so then we're talking about a lot of, sounds to me like a lot of wasted address space again.
Yes, though, again, if you look at the numbers, the amount that we're wasting right now, and that's actually in the pool for RIRs to allocate, is a tiny fraction of all v6 space that is available. They haven't even sort of put it into the warehouses yet.
But that's now. Let's talk 10 years down the road.
I will make a beer bet. I bet a beer that no matter what we do, at some point we will use this up far faster than we had originally predicted once we are stupid enough to start predicting. Because right now nobody's really predicting the run on v6 other than saying it can't possibly. Which I put in the same category as we will never have 4 million hosts on the internet, or the VP at DEC of the no one will ever need a computer that fits on their desk, or yes, or this web thing is a fad.
I wouldn't take that bet for
Yeah. So yeah, we will waste it in some stupid way, and it will be some grad student who does something like puts a data structure into v6 addresses instead of into a data structure, and manages to exhaust a /8 in one run, and it will be the cool app that everybody's kid wants. Yeah, who knows?
Well, that's kind of my take on that whole discussion. Is that if you talk in terms of absolute total quantity of addresses, it may be conceivable that it's not possible to use it given the current population of the globe and what it may potentially be in 50 years. However, it is entirely possible for us to waste it all through improper use, improper allocations, and simply treating a 128-bit network as though it's 48 bits.
Yes. Oh,
But that's
for folks, and sorry to interrupt you, if you could do your names when you walk
right.
on the mic. Yeah.
Yeah. Anyway, that's for other discussions. I'm Wayne from Limelight Networks. The question I wanted to ask was, with regards to security implications and so forth, are you aware of anything surrounding V4 and V6 or V6 and V4? That's
You mean tunneling one in the other?
yes.
They pretty much all boil down to it's a tunneling or an encapsulation issue that you need to be able to detect at your perimeter devices, and it's any encapsulation. It doesn't matter whether it's V4 or V6, so much that it's an encapsulation or tunnel. I actually did a presentation at the Phoenix NANOG, the last one, basically breaking down transition technologies, and one of the things I broke down was as soon as you say you're doing encapsulation, here's all of the stuff that's broken and all of the baggage you inherit, or if you call it a tunnel, here's all the stuff. And essentially all of those things boil down to it is a tunnel ore. That's the generic answer. The more specific is the only one that I'm aware of that is likely to be exploited because of ease of use embedded in the rest of it is the Trado that I mentioned.
Right. So essentially what you're saying is that really, in order to deal with anything in that regard, is to simply recognize that it's a tunnel, and then all the standard rules should apply.
Exactly. In the same way of, ARP cache, neighbor cache, same problem, same mediation. Oh, it's a tunnel. The fact that it's a V6 tunnel over V4 or a V4 tunnel over V6, that's not it's a tunnel, exactly.
Chris Murray, OpenDNS. I more just had a comment along the lines of IPv6 security and that being on 20 different internet exchanges around the world, I'm sure you've all seen IPv6 neighbor advertisements from peers and stealing traffic. So we still have a long way to go as network operators in getting our house in order. There's lots of routers out there with no like loopback filters, for example, to protect themselves. So,
yes, I would make the comment that there are a lot of, just like I railed on V4 code and V4 apps and all the stuff, and yes, it's all broken. There are a number of sloppy habits. We still don't have BCP38 rolled out. There are just so many sloppy habits. But in V6, in particular, yes, templating, Cymru, CYMRU, has some useful example templates on routing for security that are certainly worth looking for and putting to your policies. I will make the pitch that if you are not automating configuration, typing V6 addresses and prefixes should be the thing that drives you. If you didn't quite think it was worth the effort in V4, V6 will drive you there to automate. The advantage then also is the once you get the rule sets and you get config checks and policy checks, those go away because you light new routers with the same cleanliness as others. The last thing that I will mention is one of my pet peeves that I used to hate with Cisco. Anything that was a default, as soon as you did write conf and then show conf, the default settings went away.
yeah.
Even if you explicitly set it. They would not preserve your explicit settings of what was the default, which was really cool until they changed the default in a release, and you're now running with a setting you didn't think you had. And there's some stuff with V6 that I've seen where they are continuing that trend. So going in and explicitly doing explicit sets as part of the configs that you load in on reloads and on your other configs to make sure that you are doing the polite things. And yes, exchanges are not local wires. You should not treat them as a broadcast domain or a subnet. Be polite. Thank you.
As someone who we've had our blocks get rerouted because of that, but I think a lot of it too was World IPv6 Day. Everyone was rushing to be fully V6 and just went like put IPv6 addresses on and didn't really check anything, and that day was a bit of a mess on the IX world.
It worked much better than we expected. There were very few support calls, but yes, the trailing things of unexpected cruft. And we haven't talked really here about it, and it's not quite a security issue, but the whole preferring quad A's or A's, the whole happy eyeball and all of those other things of deciding in the resolver which address you pick is still somewhat of an unsolved problem, which has security implications as well if your V6 and V4 are not the same machines or with the same security profiles. The short explanation on that is originally Yahoo noticed this, and that was what the original World IPv6 Day was to test, was what would happen if they turned a quad A record on as the entry to a lot of websites. And they discovered there were an awful lot of brokenness in stacks and various other things. Well, they decided to have what was called happy eyeballs, because the story is users don't really care about V6, V4. They don't know what they are. They just want their eyeballs to happily see the content that they clicked on loading in their browser fast. So in order to make our users' eyeballs happy, we need to make sure that we get them an IP address, V4 or V6, that gets them the content they want faster. The IETF took too long to get the happy eyeballs RFC out, So in the meantime, what happened was Microsoft actually did the right thing. They said, we're not going to patch our browser because the world is more than the web. Oh my God, somebody said it was more than the web. We should just fix the OS stack so that it does DNS resolution with a happy eyeballs that is sane, and then our web browser will work, Firefox will work, Mail client will work, all the rest. Cool. That actually was the right choice. Apple didn't do that. Then all of the browser vendors said, well, we're already doing stub DNS resolvers because we don't trust the DNS resolvers and we don't trust the OS vendors and all the rest of it. So every single one of them implemented their own version of happy eyeballs with different metrics and different heuristics. So if you run Chrome on Windows, you get different performance than running Firefox on Windows, and it's different than running Explorer on Windows. And Apple is different, and yet again, and suddenly just complete chaos. So that's another one of those security things of you now actually have to have your help desk asking what OS are you on, what browser are you using, what level of all of these, and all these other questions before you can even decide whether it's a network or a DNS issue.
Yeah.
Andy with TDS Telecom. One thing that I wanted to point out, and I thank you for a great presentation, echo your comments that anything that has power and emits packets needs to be tested. We recently found in our own network a particular DSLAM vendor had made a wonderful choice of protection that could be turned on for any end-connected customers, allowing only multicast to go one direction. Unfortunately, that breaks all v6 because multicast is used for many of the control packets that are used.
For the rest of you, IPv6 is a multicast, not the multicast broadcast medium, multicast the non-unicast. Yes.
And so by making this wonderful feature for us in v4, they have inadvertently broken all of v6. They're working on making a fix for it, but it's one of those things that just by tweaking one little setting, your v6 completely was broken.
Oh, yeah.
So testing and making sure that all of those little knobs do what they're supposed to, if you plan to implement anything, is quite important moving forward.
Oh, yes, thank you. And other things you don't think about embedded systems, badge readers, smart power strips, wireless video cameras, all these other things that you bought some period of time ago and are useful and are v4 only and will never be v6. And you at least need to identify those so you know your problem space and you know what you're going to be, essentially asking Santa for your v6 upgrade. Other questions?
Hello, Athanasios Douitis from National Technical University of Athens. I'd like to thank you for a wonderful presentation. I'd like to ask the audience as a whole, how many of you have used IPsec over IPv6, and on which, except on vendors like Juniper, Cisco, and for example, have you used IPsec over IPv6 on Linux, FreeBSD? Sorry?
The native implementation, like what's in the stack, or are you saying outside?
Any of
Okay.
Cisco Connect, anybody's VPN.
Do you
I was just making sure I understood the question.
Yeah,
So basically, okay, let me rephrase. There's a portion of the IPsec that is operating in the kernel, and then obviously you have to have a daemon of some sort of a user space daemon that does all the internet key exchange or whatever. So the question is that, for example, you're running FreeBSD. What kind of IKE daemon are you using to do IPv6? If any.
Yeah, and I can't speak to it. Most of the folks that I've been seeing that have been starting to test it have been doing end client as opposed to Unix box. So they've been using, Mac or PC based, usually vendor supplied. And even that's kind of twitchy right now. My experience has been right now that most people doing IPsec are, in many cases, doing v4 and then tunneling v6 over v4 through the tunnel, which, yeah, 2 layers of encryption is even better, right? Thank you. All right, other questions? If not, lunch is at 1, and thank you very much for your attention.